Good morning, students. Welcome back to mathematics class. So today we'll continue that multiple choice question on the chapter set. So today we completed around 17 question. Right. So we'll start from 18th question. Before that, one of the student asked yesterday that is 10th question. Right. So once again, just explain the 10th question. So we'll see what that again the 10th question says. So 10th is about related to let R be a set of points inside a rectangle. Right. So 10th solution R. What is R? R be a set of points inside a rectangle of sides A and B with the two sides along the positive direction of x-axis and y-axis. So if you take your y-axis and x-axis, this is your x-axis, this is your y-axis, right? So two sides are along positive direction of x-axis and y-axis. So length is along positive direction of x-axis and breadth is along positive direction of y-axis. What is the length of the rectangle? A. And what is the breadth of the rectangle? B. So we are forming a rectangle, right? We are forming a rectangle whose length is A and breadth is B. Of sides A and B. Of sides A and B. What is defined? R is a set of points inside the rectangle. R is a set of points inside the rectangle. So how we can represent R? What is R? It is a set of points inside the rectangle. So what are the values of x and y it can take? So point means it is of the form ordered pair x comma y. Point means it is of the ordered pair x comma y. So how we can represent set of points in a set? R is a set consisting of set of points where inside the rectangle, not on the rectangle, right? So what are the values of x and y it can take? Suppose if I take the points on the y-axis, right? If I take the points on y-axis, what is 0? X is 0. So x cannot be equal to 0 because if I take the points on y-axis, how do we represent the point on y-axis? It is of the form 0 comma y. So if I take the points on y-axis, x equal to 0, but I cannot take x equal because if I take x equal to 0, all the points on the rectangle I am taking. So I should take x should be or more than 0. So x should be more than 0. Next, if I take the points here again on this rectangle, what is x equal to here? The point is what here? A comma 0 and this is 0 comma b. If I take the points on this again on the rectangle here, what are the values of x here? X equal to a and b. Anywhere you go, right? What is x equal to here? X equal to a and b. But x should not be equal to a. X should be less than a. I cannot take more than a also because more than a is not outside the rectangle. Means x should be more than 0 and x should be less than a. So that these points are not included, right? So the breadth points are not, these sides are not included. We want only inside the point. So first conditions are x should be more than 0 and x should be less than a. So 0 less than x less than a. These are the values of x should take. So that the sides of the breadth, the points which are on the breadth, they are excluded. Now if I take the points on this side, that is on the length side. So any point on the x-axis, what is any point on the x-axis is given as x comma 0. That is on x-axis y is 0. But I cannot take these points on the rectangle. Means y should be, what is y should be? Y should be more than 0. So that these points I'm not taking. So if I take these points, means any point on this x-axis, y is 0. But these points I should not take. Means y should be more than 0. So that already we are eliminated these points sides. Now we are eliminating these sides points so that y is greater than 0. Again, if I take the points here, right? If I take the points here, so what is y equal to here? B. Y equal to b. Anywhere you go on this line, what is y? It is b only. But these points should not be taken because these are the points on the rectangle. Means y should be less than b. Y should be less than b. So that if I take y is greater than 0, these points are eliminated. If I take y is less than b, these points are eliminated. Again, if I take x is greater than 0, these points are eliminated. If I take x is less than 1, these points are eliminated. So that the points on the rectangle are not included. Only the points inside the rectangle have been included. So that these two conditions should take. Means, what are the condition x and y? X should be like between 0 to a and y should be lies from 0 to b. So this set represents set of points inside the rectangle, not on the rectangle, right? So this was about the 10th question. That is your fourth option. I can tell fourth option is correct. Option number 4, that is r equal to x comma y. These are the points inside the rectangle such that x is lying between 0 to a and y is lying between 0 to b, such that only the points inside the rectangle have been included. The points on the rectangle, right, has been excluded. So this was about the 10th question. Now we'll go for that 18th question. So that 18th question says, 18th solution. So you're asking the set A intersection B dash whole dash union B intersection C. The set A intersection B dash whole dash union B intersection C is equal to what? So we should know De Morgan's law. So what is De Morgan's law? A and B whole dash equal to A dash intersection B dash, and A intersection B whole dash is equal to A dash union B dash. So for any two set, it satisfies these two set relation. So these two relations are said to be De Morgan's law. Complement of union of two set is equal to intersection of their complements, and complement of intersection of two sets is equal to union of the two sets. So here we can apply De Morgan's law. A intersection B whole dash is A dash union B dash. So if I take the complement result, A dash, what is complement of intersection? Union, and B dash whole dash, right? By using De Morgan's law, A intersection B whole dash is A dash union B dash, where B is on B dash, B dash whole dash union this B intersection C keeping as is. So we know that what is complement of the complement set? The set itself, right? Complement of the complement set is what? Set itself. So complement of complement B is what? D only. So it becomes A dash union B, A dash union B union B intersection C. So since we know that that is set satisfies the associative property A union B, A union B union C is same as A union B union C. So let us apply the associative property A union B union C. Let this take as what? Total C. A union B union C is what? A union, right? A union B union C. What is B? B union. What is C? It is B intersection C. Right? So I am applying associative law. A union B union C is same as A union B union C. So this is A union B union. This total I am taking as what? C. A union B union C is what? A union B union C. Next, when I take union, A dash union. So B intersection C union with what? B. So whenever if I am taking union, what is the output I am getting? Which is the bigger set I am getting as an output. So B intersection C is what? B intersection C. So every element of B are also present in B only. Every element of B intersection C are also present in B. Means I can tell B is the bigger set here. So B intersection is a smaller set. So any element I am getting B intersection C, those elements are already present in B. So I can tell B union B intersection C. I will be taking as what? B, because I am taking the union. So when I take the union of two set, which is the bigger set that I am getting an output. When I am taking the intersection, which is the smaller set that I am getting as an output. Here it is union. B intersection C, B union got B. I am getting as B is a bigger set. So which is equal to A dash union B. So A intersection B dash whole dash union B intersection is what? A dash union B, which is your second option I can tell. That is option 2. Option number 2. 18th one. Option number 2 is your correct one. Right? So okay. Let us go for 19th question. 19th one. So this is what, whenever we come across a question related to three set, so with the help of Venn diagram usually we can solve. But this question with the help of usually formula also we can solve, and with the help of Venn diagram also we can solve. So in both the way we're solving this example 19 question, which is very important. This type of examples are very important for us in multiple choice question. So of the members of three athletic teams in a school, 21 are in cricket team. Means 21 are playing cricket team. So let us take this out. N of C. N of C is equal to 21. Right. Next, 26 are in hockey. 26 are in hockey. N of H is equal to 26. And 29 are in football. N of F is equal to 29. 29 are playing football. Among them, 14 play hockey and cricket. 14 play hockey and cricket. 14 play hockey and cricket. Next, 15 play hockey and football. 15 play hockey and football. That is H intersection F. 15 play hockey and football. Right? And 15 play hockey and football, and 12 play football and cricket. 12 play football and cricket. 12 play football and cricket. Right? Next, 8 play all the three games. All three games are intersection. C intersection, H intersection, F, that is cricket, intersection hockey, intersection football. So how many are playing? 8 play all the three games, that is C intersection, H intersection, F is equal to 8. 8 play all the three games. Then total number of members in three athletic teams is, how many number of athletic are there in that team? Totally, it will be cricket or hockey or football. So total number of members means, and what you have to find here? N of C union H union F equal to question mark. This you have to find, right? So this is a given data for us. This you have to find. Right. So let us, we know this formula. What is N of A union B union C? That is total number of members in that athletic team. What is N of A union B union C? N of A plus N of B plus N of C minus N of A intersection B minus N of B intersection C minus N of A intersection C plus N of A intersection B intersection C. So this is the formula, that is N of A union B union C. Okay, let us apply this formula and we'll find total number of members in that athletic team very easily by the help of this formula we can find. So if I apply that formula, that is N of C union H union F is N of C plus N of F plus N of H minus N of C intersection H minus N of H intersection F minus N of C intersection F plus N of C intersection H intersection F. Right, with the help of this formula, N of A and B and C, N of C plus N of F plus N of H minus N of C intersection H, H intersection F, C intersection H, H intersection F, C intersection F plus N of H intersection C intersection H intersection F. So if I apply N of C union H union C, if I replace all those formulas, N of C 21, N of F is 29, N of H is 26. Minus N of C intersection H is 14, minus H intersection F is 15, minus C intersection F, C intersection F is 12, plus C intersection H intersection is 8. So if I simplify this one, your answer is, that is total number of athletic in that teams are 43 will be getting. So if I simplify this one, 21 plus 29 plus 26 minus 14 minus 15 minus 21 plus 8 means your answer is 43. That is your option. Which option it is? Option number 1. That is first option. Suppose if he is asking how many are playing only cricket, how many are playing only hockey, how many are playing only football? In that case, Venn diagram very helps us to find all those results. So this one very easy. If you are asking total number of total number of members in that total team, or else if you are asking, suppose there are a universally there are some particular numbers, and how many are playing neither of that one. Neither of that one means total, that is universal minus total number of members, that gives neither of that one. Suppose if he is asking only exactly two sports, how many are playing? Only cricket and hockey, how many are playing? Only hockey and football, how many are playing? Only hockey, cricket and football, how many are playing? Exactly two sports. In that case, Venn diagram helps us to find out those results. So let us see, this can also solve by Venn diagram. So we'll take the Venn diagram. It is set, that is cricket and hockey. Next is what? Football, right? So first we'll write how many are playing all the three games. How many are playing all the three games? Cricket intersection hockey intersection football. So this region is common for all the three sets, right? This is C intersection H intersection F. This is C intersection H. This is F intersection H. This is F intersection C, right? Suppose if you are asking only cricket and hockey, only this much part is cricket and hockey. Suppose if you are asking only hockey and football, this much part is hockey and football. Only cricket and football, this much there only cricket and football, right? And only cricket if you are asking, only this side part, right? This side part is your only cricket, only hockey and only football. So first we'll we'll put the data in that side so that we'll get a clear idea. 8 people are playing all the three games, means H intersection F, C intersection H intersection F equal to what? 8. Next, football and hockey, F intersection C. This is your F intersection C, right? This is your F intersection C. So F intersection C, how many are playing cricket and football? 12. So this total is what? 12. Already written 8 here, right? So already written 8. So total 12 are playing in that. 8 are also playing what? Hockey also. So that should be taken into that we have taken here already 8, right? So 12 minus 8 is equal to what? 4, I can tell, right? So 8 plus 2, 8 plus 4 is equal to what? 12. So totally cricket and football, how many are playing? 12, right? Cricket and now F intersection C. This is your F intersection C. So this is completed. This is also completed. Now hockey and football, how many are playing? 15. Hockey and football means this region, right? So this region is your hockey and football, H intersection F. How many are playing hockey and football? 15. In that 15, already are written 8 are written, right? So in 15, 8 are there, they are playing cricket also. So this comes under all the three. So already written 8 here. 15 minus 8, right? 15 out of 15, if you remove 8 is equal to what? 7 in 15, 8, 7, right? So 7 are playing. So total 8 plus 7 is equal to 15. That is hockey and football. Equal to 15. That is your H intersection F. So this also is completed. Now hockey and cricket. This is hockey and cricket. So this is your C intersection F. Sorry, C intersection H. That is hockey and cricket. C intersection H. How many are playing hockey and cricket? 14. In that 14, already written 8, right? Already written 8. Then how much? 14 minus 8 is equal to how much? 6, right? So 6 I can tell. That is 6 plus 8, 6 plus 12, 14. So 6 plus 8 is equal to 14. So H intersection C is equal to 14. Now all the data you have given inside. Now we'll find what is N of F, right? So what is N of F is what? N of F is equal to total number of people playing football. This is your N of F. So in N of F, already this total is your N of F. So N of F is equal to 28. Already written 7, 8 and 4, 15, right? So 7 plus 7, 14, 15. 15 plus 4 is equal to 19. Then how much? 29 minus 19 is equal to how much? 10 I can write. So that total F, if you take, it becomes how much? 29. 10 plus 7 plus 8 plus 4, that is total number of people are playing football is what? 29. In that 7 are playing football, others hockey, 4 are playing cricket, others football, and 8 are playing all the 3 games, right? And how many are playing only football? Only football is on this region is your only football. How many are playing only football? Only 10 are playing. Next, let us come for so F is over. This also is over. Next, H. How many are playing hockey? 26. So this is your hockey. This is your set hockey. So how many are playing hockey? 26. In that 26, already written 6, 8, 7, right? 14, 15, 15 plus 6 is 21. So in that 20, already written 21. So 21 you are written is what? 26 minus 20 is what? 5. So 5 are playing only hockey. So total, if you add this one, right? So totally, if you add this one, how much are you getting? 26 you are getting, right? So in that, 8 are playing hockey, cricket, football. 7 are playing hockey and football. 6 are playing cricket and hockey, and 5 are playing only hockey, right? Last, cricket. How many are playing cricket? 21. So this is your set cricket, right? So in cricket, how many are playing cricket? 21. In that 21, already written 6, 8, and 4. 6 plus 4 is what? 10, 18. Already written 18. 21 minus 18 is what? 3. 21 minus 3 is what? 21 minus 8 is what? 3. Means total, if you add this one, it becomes 21. So in that total 21. How many are playing cricket and hockey? 6. How many are playing cricket and football? 4. How many are playing cricket, hockey, and football? 8. And how many are playing only cricket? Is what? 3. Right? So this is with the help of Venn diagram. What is asking question? Easily we can tell. Right? So suppose if we are asking how many number of people are playing exactly 2 sports? Exactly 2 sports means this you have to add. Cricket and hockey, how many are playing? 6. Hockey and football, how many are playing? 7. Cricket and football, how many are playing? 4. 6 plus 4, 6 plus 4 is 10. 10 plus 1 is equal to 17. So 17 people are playing exactly 2 sports, right? And how many are playing exactly 1 sports? Exactly 1 sports means what? Only cricket, only hockey, only football. How many are playing only cricket? 3. How many are playing only hockey? 5. How many are playing only football? 10. 10 plus 1, 15. 15 plus is equal to 18. 18 people are playing exactly only 1 game. So this what whatever question is asking, that we can solve very easily with the help of Venn diagram. So but here is asking how many number of people are there? N of A, Union B, and C. So they easily with the form N of A plus N of B plus N of C minus N of A intersection B minus N of B intersection C minus N of A intersection C plus N of A intersection B intersection C. Right. So by this we can easily get this result. Right. Okay. Now let us go for next question. 20th question. 20th question also same. Right. 20th question also same. So just write the given data. We can write by yourself with the help of Venn diagram. So 20th question is. And suppose if you are asking how many are playing neither of the games, neither cricket nor hockey nor football. Suppose there are over 800 people. So 800 universal minus how many are the team. So that gives your outside part. That is neither cricket, neither hockey, neither football. That is your outside part. Suppose if you are asking that value, that is universal minus total number of people. Right, so that is the outside part, which indicates they are playing. Those people are neither playing cricket, hockey, or football. Right. Okay, 20th one. Out of 800 boys, right, in a school. So out of 800, totally how many boys are there? 800. So N of U is equal to 800. Out of totally all have been included. Out of 800, that's all. There is no particular group of people. Totally all have been included. So that indicates your universal set. N of U is equal to 800. 2 to 4 played cricket. Means N of C is equal to 2 to 4. 224 played cricket, 240 played hockey, 240 played hockey, 240 played hockey, and 336 played basketball, 336 played basketball. Of the total, 64 played both basketball and hockey. Basketball and hockey is 64. 80 played cricket and basketball. Cricket and basketball is 80. 80 played cricket and basket, 40 played cricket and hockey is 40. 40 played cricket and hockey, 24 played all the three games, cricket, hockey, as well as basketball. How many are there? 24. 24 played all the three games, cricket, hockey and basketball. What is asking? The number of boys who did not play any game. Number of boys who did not play any game. Suppose they are asking number of how many number of boys are there? That is same you have to find. Then universal minus that number of boys, that is the number of people that play who did not play any of the game. Means what you will find here? C union H union B whole dash. That is neither cricket, neither hockey, neither nor football. So how to find n of A and B and C? N of U minus n of C union H union B. So that you have to find. So how many of them did not play? Did not play any game. That is n of C union H union B whole dash. What is that formula? N of U minus n of C union H union B. A dash. What is A dash? U minus A, where A is C union H union B. Right. So this you have to find by using formula. N of C union H union B is n of A and B is in the same formula. N of A plus n of B plus n of C. What is C here? B. N of C minus n of C intersection H minus n of H intersection B minus n of C intersection B plus n of C intersection H intersection B. Right? So n of C union H union B. N of C we know it is 224. N of H is 240. N of B is 336. Now B is 336. C intersection H is 40 minus H intersection B. H intersection B is 64. C intersection B is 80 plus C intersection H intersection B is 24. If you simplify this one, you are getting as 640, right? If we simplify this one, everything as 640, then n of C union H union B whole dash n of U is what? 800 minus 640. That is total number of person minus those are playing. That gives neither of them game are they are playing. That is 800 minus 640 is what? 160 can end. So 160 is your which option? Fourth option. Option 4. Right, even for this problem also we can solve with the help of Venn diagram. Suppose if you are asking exactly one sports, right? So with the help of Venn diagram also we can solve very easily, right? I hope this type of example you got clear idea how to solve this step, that is verbal problem related to set, right? That's what. If two sets are very easy, again 3 sets means it becomes a bit difficult. If I take again more than 3 sets, again more difficult it becomes. But for our syllabus, it is the maximum. Only examples are related to 3 sets only, right? So 3 sets is little bit difficult, is it? Just you have to a little bit in a correct way, you have to solve that one so that your answer is correct. 2 sets is very easily you can solve for those kind of examples, right? Okay, this was about the 20th question. Now 21 question. Right? So okay, let us go for 21 question. What is 21 says? In a survey shows that 63% of the Americans like cheese. Okay, survey means total, all have been included. All have been included, total in 100%. So n of U, survey is the n of U. N of U is equal to 100%. Right? So 100% is how many people are there? 100 people are there. Right? Of 63% of the American like cheese, right? So 63. Let us take that cheese as B. N of B equal to 63. 63% like cheese. 63% is what I'll consider out of 100. 63 people are liking cheese. That is for calculation purpose. Easily we'll take as well instead of 63%. I'll take that 63 people are liking cheese out of 100 people. And 63 people are liking cheese, whereas 76 people like apple. N of A, I'll take as N of A. How many people are liking apple? 76% they are liking apple. So just I'll take as 76 members out of 100 members, 76 members are liking apple. If X% of the Americans like both cheese and apple, both cheese and apple, B intersection A equal to X%. Let us take result value as X. Then what is X equal to? What is X equal to? Whether X equal to 39, whether X equal to 63, or X lies from 39 to 63, or none of this. Okay, we know the formula N of A union B. I'll use N of A union B. What is N of A union B? N of A plus N of B minus N of A intersection B. Right? So N of A plus N of B minus N of A intersection B. That is the formula is there. We'll use that formula. Minus N of A intersection B. So N of A union B is equal. What is N of A? 76. What is N of B? 63. What is N of A intersection B? X, that we don't know. Right? So minus X if I take side becomes plus X, right? Is equal to it is 9. 139 minus N of A union B, right? So plus N of A union B if I take it becomes minus N of A union B minus X if I take it becomes plus X. 6 plus 3 is what? 9, 12, 139. Right? Now we don't know what is N of A union B. So that if we substitute what is N of A union B, directly get the X value. But we know that A union B, right? A union B is always subset or equal to universal set of. Whether A union B can be more than universal? No. Universal is a bigger set. Always A union B or A union B union C, whatever set we take, these are the subset of universal, which takes all the set into consideration. So this is the bigger set. So whatever union I am taking, which is always subset to universal or it may be equal to universal. Among these, any one condition satisfied, right? So A union B is always subset or equal to universal set. Implies N of A union B is less than or equal to N of A union B is less than or equal to N of U. Number of elements present in A union B is subset means it may be lesser, subset means it means lesser, equal means equal to universal. So number of elements present in A union B is always less than or equal to number of elements present in universal. So what is N of A union B taken as N of A union B? N of A and B. Okay. N of A and B is what is N of U? What is N of U? 100. Right? Okay. N of U is equal to 100. So N of A and B. If I take maximum elements, what are the maximum elements? 100. If I take maximum elements in A and B, I will take minimum common. Right? If I take all elements in all the maximum possible elements in A and B, how many common I will be taking? Minimum common. So if I take total N of A and B, N of A and B is equal to 100. Totally maximum how many elements are there? 100 elements are there. So if I take all the 100 elements in A and B, I will be taking the minimum common. So when I take N of A and B is equal to 100, right? So N of is equal to 139 minus 100. So X equal to 139 minus 100 is what? 39. Means this is the minimum value. Means X should be greater than equal to 39. So when I take maximum number of elements in A and B, I will take minimum common. Minimum is what? 39 getting, because what is X here? Number of common elements in A and B. So when I take A and B is the largest set. So what is maximum elements in universal? It is U. So if all the elements are taken, I am taking A and B. That indicates I am getting the minimum common. Means x should be greater than equal to 39, we can tell. Next, if I take a and b is equal to 100, I am getting minimum common. What is minimum common? 39. Among these two sets, right? So among these two sets, maximum how many common I can take? This is A and B, right? It is 63 and 76. Maximum how many common I can take between these two sets? Maximum I can take 63 common. Means x should be less than equal to 63. So minimum common is 39 and maximum common is 63. Means x should be lying from 39 to 63. You cannot substitute directly n of a and b is equal to 100 and write x equal to 39 because we don't know what is n of a and b. We know only universal. Depend upon the relation, I am checking. So if I take maximum elements in A and B, I am getting minimum common. What is maximum I can take in A and B? 100. So if I take 100 in place of A and B, I am getting 39. This is minimum common I am getting in A intersection B, right? And what is maximum common I can take between these two sets? Maximum common is 63, the 69. Can we take 76 as common between these two sets? No. Maximum I can take 63 common. So 63 is the maximum, that is it is less than, I cannot take more than 63. So which implies x is lying from 39 to 63, right? So this is your correct option. So which option it is? Your third option is correct. Option 3 is correct. So minimum common is 39 and maximum common is 63. So this was about the 21 question. Now we'll go for 22. I think 22 already we solved. This is the same question. It is repeated once again, I think. So it was which question? This 7th question it was, right? So 22 is what you define n of A union B or dash n of u minus n of A union B, right? So n of u is, it was 20 minus 17 is equal to 3. So 22 is your fourth option is correct. Option 4, right? 22 is already solved in today's class. Now 22 is over 23. 23. What is 23 says? The shaded region in the given figure. The shaded region in the given figure. Solution. So what is that figure? Let us draw. So there he has not given universal, just that indicates it's a universal set is there. It is a universal set, rectangle, set A, set B, and set C. A, this is C, this is B. So this third part is asking, what is this shaded region? Right? This shaded region is nothing but only A na. This shaded region is nothing but only A, because in total A, this total you are removing. So B part you are removing, other C part also you are removing. Only A it is. So it is only A. Only A. Or but only A is not given in the option. So this I can also write as A minus. A minus, this is B union C now. What is B union C? This total is B union C. So in A, what you are removing? B union C removing. Means B part I am not taking, C part I am not taking. Means in A, if you remove B union C, that is your A only. That is the shaded part that indicates A minus B union C. In A, which you are removing, which part you are removing? Minus. Which part you are removing? B union C part you are removing. So this is your B union C part. So nowhere B and C are not included. So A minus B union C is a your A only, you can tell. That is your option number 4. Option 4. The shaded region indicates A minus B union C. 24. If A and B are not disjoint, if the A and B are not disjoint, means A intersection is not equal to null set, right? So A intersection B is not equal to null. Implies n of A intersection B is not equal to 0. Right? Number of elements in A intersection not equal to 0. If they are disjoint, means number of elements in A intersection B equal to 0. Then what is n of A and B? Right? What is n of A and B? N of A plus n of B minus n of A intersection B. If they are disjoint, then this becomes 0. Then n of A and B will be n of A plus n of B if they are disjoint. But here what is given? They are not disjoint. Not disjoint means definitely our formula will be n of A and B equal to n of A plus n of B minus n of A intersection B. Which option is correct over there? Second option is correct. If they are disjoint means that time first option is correct, right? But here yes, we are not disjoint means A intersection B is not equal to 0. That is option 2. Option 2 is correct, right? Now 25. Okay, this I think this question we discussed in yesterday's class. Set A and B have 3 and 6 elements respectively. Means n of A is equal to 3 and n of B equal to 6. Right? What is the minimum number of elements in A and B? Right? So yesterday I think yesterday's class we had written note minimum and maximum number of elements present in A and B and A intersection B. What is asking? Minimum number of elements in A and B. So minimum number of elements in A union B. So to get minimum elements in A and B, so minimum is still reliable, right? So for that reason, what I should do? I should take maximum common, right? So maximum common, how many I can take? Maximum here 3 is there, here 6 is there. Maximum I can take 3 as common, right? So if I take 3 as common, 3 more elements are left out which are different. So 3 plus 3 equal to 6 I can tell. That is minimum number of elements in A and B equal to 6 I can tell. That is the formula written. Minimum of n of elements in A and B is equal to maximum of n comma n. So which set has maximum number of elements? Those many minimum number of elements you can find in A and B. And what will be maximum number of elements in A and B? Maximum I should take maximum. I should take in A and B. Means I should take minimum common. What is minimum common? I can take 0. Right? Maximum I can take 3 as common. Or we want minimum common. 2 I can take, 1 I can take, and 0 I can take. If I take 0 minimum common, I will take maximum output in A and B. This was minimum output in A and B. So I want maximum output in A and B. Means I should take minimum common. If all are different, these 3 elements are different, these 6 elements are different, means that indicates I am getting maximum elements in A and B. Can we get 10 elements? No. Maximum I can take 9 elements only, right? So maximum number of elements in A and B will be 3 plus 6 equal to 9. So I can tell that union of these two, union of A and B lies from 0 to 9. So minimum is 6 and maximum is 9. But he is asking, what is asking? Minimum is 6. That is your second option is correct. Option 2 is correct. Minimum is asking. Suppose if you are asking maximum, that time 9 is correct. Right? So this was about the 25th question. Now we will discuss 26th question. What is that? 26th question says, one. Each set XR contains each set XR contains 5 elements and each set YR contains 2 elements and union. So this symbol is a union. Union from R runs from 1 to 20. XR is equal to S is equal to union R runs from 1 to N YR, right? This here YR. If each element of S belongs to exactly 10 of the XRs and to exactly 4 of the YRs, then what is the value of N is equal to? Okay. Each set XR contains how many elements? 5 elements. So this indicates union R runs from 1 to 20. Means R replace R is equal to X1 union, replace R is equal to X2 union, replace R is equal to 3 X3 union. Means it will be X1 union x2 union x3 dash dash up to so on where x of 20 is equal to, right? So if it is r is equal to 1, 2, 3 up to 20. This is union. X1 union x2 union x up to so on x20 is equal to what? Yes for there is equal to yes. Is equal to yes is equal to again union r is from 1 to n. R is equal to y1, r is equal to y2, r is equal to 3, y3 union, r is equal to n union yn. So if it is r is equal to 1, y1. Next is what? Union. Next r is equal to 2, y2 union. Next r is equal to 3, y3 union. Dash dash up to so on union. R is from 1 to what is the last number here? N. Means it is yn. Yn. Right? So this is yes given. So 20 sets are there. Union of this 20 set is equal to yes, and n number of sets are there. Union of this set again is equal to yes. He is telling each set XR. Each set XR means what? XR. XR means what? X1, X2, X3, X4, X5 up to X20. Each set contains 5 elements. Each set contains 5 elements. Let us assume that all those 5 elements are different. Let us assume that all those 5 elements are different. So each set is having how many elements? 5 elements. 5 into, then if I take union of those all the 20 sets, 5 into 20, I am assuming all 5 elements are different. Right? Let us assume all those 5 elements are different. Each set contains how many elements? 5 elements. So 5 into how many sets are there? 20. So 5 into 20 is equal to 100 elements are there in union of this 20 set. Is equal to yes is equal to again what is given? Each set yr contains 2 elements. So each set y1 is consists 2 elements, y2 is consisting 2 elements, y3 is consisting 2 elements, up to so on. Yn is consisting of 2 elements. Let us assume those 2 elements are different. So each set is having 2 elements. If I take union of this one, means it will be 2 into n. Right? So these are the elements in union of this set, and 2 5 into 5 2s are 10. 100 elements in union of this 20 set. Yes is equal to 2n. Next, again what is going to see? If each element of yes, what is yes here? You know this x, you know this y. Each element means 100 elements are there. 100 elements are there. Each element of yes belongs to exactly 10 of the xr's. Means when 100 elements are there, one element if I take from 100, that one element is belongs to 10 of the xr's. Means that one element is present in x1, x2, x3, x4, x10, or it may be x2, x3, x4 up to x11. So that each element is present 10 of the xr's, any 10 of the xr's. So in that case, I should divide by 10 because each element present 10 of those sets. So I should divide it by 10 is equal to again what is given 10 of the xr's and exactly 4 of the y's. So in union of these sets, we are having 2n elements. In each element is present 4 of the y's. So one element, if I take among these 2n elements, that single element is present in y1, y2, y3, y4, or y2, y3, y4, or y5. Right? So that single element is present in 4 of the y's. So I should divide it by 4. So 0, 0, it cancel. Here 10 is equal to yes is equal to 2 ones are 2 2s are n by 2. So 2 10s are 20. So 20 is equal to yes equal to n implies what is n is equal to 20 again 10. Right? So the value of n is equal to 20, which is your second option again 10. Option 2. Right? Option number 2 is the correct one. That is your 26th question. Now similarly, same you can try for 27th question also. Same it is, right? Just instead of 5 and 2, there are some different elements. So let us try that 27th question also. 27th question. Suppose A1, A2, A3 up to A30. 30 sets are there. are 30 sets, each having 5 elements, and B1, B2, B3, Bn, n number of sets are there, are n set, each having 3 elements. Let union of I runs from 1 to 30, I runs from 1 to 30, AI is equal to union of J runs from 1 to n, Bj equal to yes, right? So union of AI means I is equal to 1, union I is equal to 2, union I is equal to 3, up to so on, I is equal to 30. So if we replace I is equal to 1, A1 union A2 union A3 union A4 dash up to so on union AN. Right, so not AN, how many are there? 30. 30 sets are there. 30 equal to union of J runs from 1 to n, J equal to 1 B1, union J equal to B2, union Bj equal to 3, B3 up to so on Bn. So B1 union B2 union B3 union dash union Bn, right, equal to yes, so 30 sets are there, here n number of sets are there equal to yes. What is given? Suppose the 30 sets, 30 sets, each having 5 elements. Each having how many? So this is having 5 elements, this is having 5 elements, this is having 5 elements, this also having 5 elements, this also having 5 elements. 30 sets has 5 elements each. Now let us assume that all those 5 elements are different. Then total number of elements in all these 30 sets are 5 into 30. Right? So these many elements are there in all union of this set. Union of all the 30 sets is equal to again 5 elements is, and B1, B2, B3 has 3 elements. So in these 3 elements, in these 3 elements, in these 3 elements, let us assume all those 3 elements are different. So if I take union of all these Pn, so how many number of elements are there? 3 into n is equal to yes. 5 3s are 15. 150 is equal to 3n is equal to yes. Again, further what is given? See, right? Further what is given? And each element of yes. What is yes? 150 as well as 3n. Each element, right? So single element, each 150 elements are there. Each element of S belongs to exactly 10 of the AIs. So among 150, one element if I take, that one element is present in 10 among the AIs. Means it will be present in A1, A2, A3 up to A10, or it may be A2, A3 up to A11. So that single element present in 10 among the set. So I should divide it by 10 is equal to 10 of the AIs and exactly 9 of the BIs. So 3 elements are there. Each element is present in 9 of the BIs. 9 of the BIs means it will be B1, B2, B3, B4, B9. It will be B2, B3 up to B10. The single element present in 9 of the BIs. So I should divide it by 9. Right? So 0, 0 get cancelled. 15 is equal to 3 ones are 3 3s are n by 3 is equal to yes. Right? So 15 3s are 15 into 3 is equal to n equal to yes, implies 15 3s are 48. Sorry, 15 3s is 45. N is equal to 45. So these two are similar example, right? So just to take these two problems. This completes your 27. Now 28th question, right? What is 28th question? So last problem was n is equal to what? 45. 15 3s are 45. 28th question, capital A. Capital A equal to x such that x is not equal to x. What it represents, right? What it represents? First option, whether it represents 0, if I take 0 here, 0 such that 0 is not equal to 0. No, 0 is equal to 0. No. So this set does not represent first option. Second option, empty set. Whether empty set represents this one? Yes, surely if I take any number, 4 is not equal to 4, 4 is equal to 4, 5 if I take 5 is not equal to 5, right? 5 is equal to 5, means either any such element which is not equal to that number, no, there are no such element which is not equal to that number, means we cannot write any element to satisfy this condition, x is not equal to x. If I want to write 5 says that 5 is not equal to 5, no, 5 is equal to 5. So any element is not satisfying this condition. There are no such element x such that it does not satisfy this condition. So all the elements are equal to itself. So this, what it represents? It represents an null set, right? So even this I can call as representation of null set in set builder form. One example, give an example of null set in set builder form. X such that x is not equal to x, means there are no such elements which are not equal to itself, right? And third option, what is the third option? Is 1. Third option is what? 1. It is saying whether the set 1 represent this one if I take the element 1, if I take 1 for set, 1 is not equal to 1. No, 1 is equal to 1. So this also not represent this set for third option. So even fourth option. What is fourth option? What is fourth option? X it is, right? So x says that x is not equal to x. No, x is equal to x, right? So I cannot write x is not equal to 2x, you can write. But x is not equal to x, how you can write? Because they are same only, right? So depend upon x value here I can tell x not equal to x, but here x is equal to x only. 4 is equal to 4, 5 equal to 5, right? 6 equal to 6. So such that there are no such elements x not equal to x. So which option is correct? Second option is correct. This is your 28 one. 29. What is 29? The result of intelligent student in a class. The word intelligent, right? We cannot tell it varies from person to person. Based on this particular character only, we cannot tell this is intelligent, right? The word intelligent is not well defined, because what is said, it is a well defined collection of objects. So when you are making the collection, you should not be in a dilemma whether I should take this element or I should not take this element. The word intelligent varies from person to person. So I can tell that the set of intelligent students in a class is not a well defined collection. That is 29. 29. Which option is correct? Option 4. It is not a well-defined collection of objects. Let us go for 30th question. Okay, the set A equal to x such that x belongs to R, x square equal to 16, and 2x equal to 6. Okay, A is a set which is consisting of some element x, such that what type of elements it is? X square equal to 16 and 2x equal to 6. The word and indicates it is the intersection, right? What is the common element between these two equations you have to find, right? So those elements are your elements in set A. Okay, if I equate x square equal to 4, x square equal to 16 implies x equal to what? Plus or minus 4. Next here 2x equal to 6, x equal to 3. Any common term between these two elements? Right? No. It is plus 4 or minus 4, it is what? Plus 3. So there are no such common term between x square equal to 16 and 2x equal to 6, because the and is an element which satisfy this equation, otherwise this equation should write in the set A. But there are no such element to satisfy these two equations. That is, it is an empty set, we can tell. That is 30th one, it is empty set. Option 1. Option 1. 31st solution. 31st. Which of the following is the empty set? Which of the following is the empty set? So first option, if we take, what is first option? X such that x is a real number and x square minus 1 equal to 0. If I solve this one, right? If I solve this one, x square equal to 1 implies x equal to what? Plus or minus 1. Whether plus or minus 1 is a real number? Yes, definitely it's a real number, belongs to R, right? So because x is a real number, is saying first option, what do you say? Which of the following is an empty set? No, this is not an empty set. It consists of elements, two elements, 1 and minus 1. So this option fails. Second option, x is a real number such that x square plus 1 is equal to 0. X square plus 1 equal to 0 means x square equal to what? Minus 1. Implies x equal to what? Plus or minus root of minus 1. What is under root minus 1? It is an imaginary. It is not a real number. So x equal to plus or minus under root minus we call it as what I, imaginary number, which is does not belongs to real number. Means there are no such elements which satisfy the equation x square plus 1 equal to 0. Only the imaginary number satisfy this equation. No such real numbers are there. But he has given x is a real number. There are no such real number which satisfies x square plus 1 equal to 0. Means I can tell this represents an empty set or a null set. Right? So if the question is related to empty set only, which of the following is an empty set? Second option is the empty set. I can tell option number 2. Right? Option 2 is the empty set. This is also about the 31, 32. Let us go for 32 question. This again similar type we saw in yesterday's class. Two finite sets have m and n elements. N of A is equal to m, n of B is equal to n. Two sets has m elements and n elements, right? What is telling? The number of subset of first set. What is total number of subset of first set is given by 2 raised to m. Because if a set has m elements, total number of subset is 2 raised to m. If a set has n number of elements, total number of subset is 2 raised to n. Number of subset of the first set is 2 raised to m. Subset of the first set is equal to 1 time. Sorry, 1 Number of subset of the first set is 1 more than that of the number of subset in second set. Means total number of subset in first set is equal to 1 plus total number of subset in second set. What is second set here? Total number of subset? It is 2 raised to n. So plus 2 raised to n, if I take it becomes minus 2 raised to n is equal to 112. So now we're checking the option wise, right? So which option satisfies the value of m and n? That is you can tell the correct, that is the value of correct values of m and n. So difference of powers of 2 should be equal to 112, or 112. How we can express difference of powers of 2? If I take m is equal to 7, 2 raised to 7 minus 2 raised to 4 is equal to 112. We are getting, so 2 raised to 7 is what? 128, or 2 raised to 4 is what? 16, right? 128 minus 16 is equal to what? 112. So 128 minus 16 is 112 is equal to 112, implies m is equal to 7 and n is equal to 4. Implies the value of m is 7 and n is 4. Okay. So by checking the option wise, you have to find the values of m and n. This is 32, 33. Let F1 be the set of parallelograms. So F1 is a set of parallelograms. This is your F1. F2 is a set of rectangles. F2 be the set of rectangles. F2 be the, this is your F2. F3 be the set of rhombus. This is your F3. F4 be the set of squares. F4 is a set of squares. F5 is a set of trapezium. Trapezium are two sides are parallel and other two sides are non-parallel. That is your trapezium. This is your F5, right? Then F1 may be. So F1 may be what? So F1 may be the first option F2 intersection F3, F3 intersection F4, and F2 union F5, or F2 union F3 union F4 union F1. So any of these rectangle, rhombus, and square. They are the what? Types of parallelogram. They are the families of parallelogram. Means trapezium again trapezium we cannot call it as a parallelogram, right? So any of this trapezium we cannot take at all because trapezium cannot be equal to parallelogram. So now you have to consider this rectangle, rhombus, and a square. So if it is a rectangle, it's a rhombus also. If it is if it is rectangle, if it is rectangle, it's a parallelogram. If it is rhombus, means it is a parallelogram. If it is square, means it is a parallelogram. These are the types of parallelogram. So parallelogram where diagonals are equal becomes rectangle, where all sides are equal but diagonals are not equal, rhombus. All sides are equal, diagonals are also equal, it's a square. So trapezium, we cannot call trapezium as an parallelogram. So F5 cannot take it all, this we can eliminate F5. F1 may be equal to what it is asking. So first option if you see, first option F2 intersection F3. Whether if I take intersection of these two, right? With intersection of these two, whether I'm getting is a parallelogram. Parallelogram, pair of opposite two sides of parallel is equal. If I take intersection, there are no some common because here all sides are equal. Here only pair of opposite two sides are parallel equal. So F2 intersection F3 cannot call it as a parallelogram. Second option, if you see, second option it is F3 intersection F4. F3 intersection F4. F3 is rhombus. F4 is square. If I take the common, again here all sides are I am getting is equal. But a parallelogram, pair of opposite two sides are parallel is equal. Even F3 intersection F4 is also not a parallelogram. And third option, if you see, third option is F2 union F5. F2 union F5. So F2 union F5 is a trapezium, this is a rectangle. Like if I take union, I am not getting as a parallelogram. So F2 union F5 is also not a parallelogram. But if you see fourth option, what is that fourth option? It is F2 union F3 union F4 union F1. So if I take union of this one, I am getting as a parallelogram because these are the types of parallelogram. Union with what? F1. So F1 is the bigger set here. These are the subset. When I take union with F1, I am getting definitely as a parallelogram. I am getting because it is F2 union F3 union F4 union F1. F1 is a bigger set. So if I am taking the union of this one, bigger set I am getting as an output is a F1. I can tell. So F1 I can express as what? F1 is equal to F2 union F3 union F4 union F1. So if I take all the union of this one, I am getting as an F1 because union with F1, I am getting a union with a bigger set. Which is the bigger set here? Parallelogram. These are the rectangle, rhombus, squares are the subset of this parallelogram. So if I take union, bigger set, I am getting an output, that is F1 is the bigger set. So this was about the 33 question. Okay. I'll stop here. So remaining are all examples are very easy. You can try it by yourself, and later I will be giving the key answer for those questions also. Right? Okay. Thank you, students.